Hello, this is Frederik Dostal from Analog Devices, live from the PCIM booth 2016. And I would like to show to you the demonstration we have for you today. It's an energy harvesting demonstration, and it's showcasing actually a pre-release part, which it's going to release very soon. It's called the ADP 5091, and it's a new energy harvesting chip. And I can show the demo to you. So the blue board here on the table, it actually has a solar panel, it has the energy harvesting chip, and it also has a battery that we're charging with the energy we get from the solar cell. And the nice unique thing about this part is that it has a very fast cold startup mode, so it can start up when there's no voltage on any node on the board within a very short amount of time. And that's an improvement to the previous parts that we had. And additionally, it is generating one voltage to charge up the supercap or the battery, but also it's generating a second well-regulated output voltage. And we're using a really interesting concept called the SIDO concept, S-I-D-O, single inductor dual output concept. So we have one regulation loop for maximum power point tracking. And then we piggyback off of that switch node with the same inductor, and we grab some of the energy and have a second control loop to generate a fixed 3.3 volts or 2.5 or 1.8 or whatever you need. So this is very useful in many applications that need multiple voltages, or also in applications where you want to charge a lot of power on the supercap and have the supercap voltage, let's say at 5 volts or so, but still have an accurately regulated 3.3 volts for your system. And if you want to see on that screen, we are measuring the input current and the output current and calculating the output or the input power. And then we have the input voltage and the output voltage and the charging power, which would be then the output power. And so you can see all the values. And if I cover the solar panel with my hand a little bit, you can see the charging power going down and also the input power going down. It's just a neat little setup because it's not so easy to evaluate an energy harvesting system because you have voltages in the microvolt range or in very low voltage range. If you have microamps and current flowing and microwatts, then it's very easy to get measurement errors into your setup, in your measurement setup. So we use high-side current sense op amps on that board, and we make sure that none of the supply power is actually leaking into our energy harvesting circuit, because otherwise it wouldn't be really a very trustworthy measurement setup. So we're showcasing this here also. And last but not least, without stealing too much time off you, this is a real application then with the same chip. So it has the solar panel, it has the energy harvesting chip, and it has a wireless sensor network board. And that wireless sensor network board has different types of sensors, and then we wirelessly communicate with a mesh network onto a different board that I have set up here. And I can actually read data about temperature, about humidity, about moisture, and all these things wirelessly, all from an energy harvested application using no batteries whatsoever. On the bottom side of the board you can see we could have batteries there, but it's right now just running off of the solar panel. And this was pretty much an introduction to the demonstration, to what I'm showing here today. Thank you for watching, and see you next time. Bye.